Welcome to Padhaibook classes. In this video, we are going to talk about remainder shortcuts. This is not a remainder theorem, but this is a technique on how to find a remainder of certain numbers easily. Now, you may know that you may be given a question like this as it is written on the screen, like 17 upon 6. But sometimes you may also be given the question in the form like what is the remainder when 17 is divided by 6, or what is the remainder when 18 is divided by 5. You can convert that mathematical problem into some mathematical equation like this. You can write 17 by 6 on your own, and then we will learn how to find learn the trick of this question. We'll start with a very simple example as usual. Now, before we start with the first example, I would ask you to subscribe to this channel if you haven't subscribed to this channel, and you can share it with your friends as well. Alright, moving on, this is our some hard trick series that can also be used for some competitive exams if you are preparing for that. Nevertheless, they are always useful for you in any kind of mathematical related field if you are working. Alright. Let's start with the first example. Our first example says that 17 upon 6, or we can say that when 17 is divided by 6. Now, as we all know that when we learn the multiples of 6, the 6 has multiples like 6, 12, and the next one is 18. Now, what we do is we see the numerator and we check to which number this is much more close. Is it more close to 12 or is it more close to 18? It is definitely more close to 18. So, what do we do is we say that this is 1 less than the next multiple. So, we write as minus 1 on the numerator. Alright. We write that minus 1 on the numerator. Now, minus 1 we get after dividing that if this is 1 less than the next multiple. Now, we take the denominator. Now, since it is a negative number, and we know that remainder can never be a negative number. So, what do we do is in that case we take the denominator and we subtract the number that we wrote on 17, that is minus 1. So, 6 minus 1 is 5. The 5 is the remainder. It's not the answer, it's the remainder. Alright. You're not getting your dividing or something like that. It is the remainder that we get. Similarly, let's take another example. The another example is 18 upon 5. Now, as we know that the more multiples of 5, we know that we have to write the shorter number always. We cannot write the bigger number. Like for example, in this case, you can also write plus 3 or minus 2, but we always go for the shorter number because it makes the calculation easier. So, let's take minus 2. Now, as you can see, we took minus 2 in this example. Now, what is the remainder that we will get? We will subtract minus 2 because minus 2 cannot be a remainder, it is a negative number. Negative numbers cannot be a remainder. We know that from our primary classes. Alright, 5 minus 2 is 3. Now, 3 is the remainder. Fine. Let's take another example. Next example says that what remainder we get when we divide 31 by 7. The remainder that we get is, as you can see, is the remainder is plus 3. Now, plus 3 is the remainder. Now, plus 3 is a positive number. Now, in this case, we don't have to do anything. The remainder directly is, I am writing R for the remainder. The remainder in this case is directly 3. Alright. Let's take next example. The remainder is plus 1. As we know that when 82 is divided by 3, the remainder is plus 1. So, remainder is 1 in this case. Alright. Now, why we learned this type of questions? Because this can also help us in more complicated problem like this that we will be encountering in the next example, as you can see. Look at this example, 49 multiplied by 65 upon 6. Now you are not supposed to do the actual calculation. You are not supposed to find 49 into 65 and then find the remainder and all that. There is a very shortcut technique that you can use to solve this. For example, you are given 49. Now the remainder when 6 is divided by 49 is 1, and the remainder when 65 is divided by 6 is plus 5. Now we see that there are two numbers that we wrote on the numerator side, that is plus 1 and plus 5, and the sign between them is multiply, as you can see. Then the remainder will be 5. Alright, similarly in the next question, as we see that we are given 71 multiplied by 19 divided by 8. Now as we know that 71 is just one short of the 72, which is a multiple of 8. Similarly 19 is 3 more than 16, which is a multiple of 8. The numbers that we wrote is minus 1 and plus 3. The sign between them is multiply. So what number we get is, the number that we get in the numerator is minus 3 after multiplying these two. Now since minus 3 cannot be a remainder, then what we do in the previous case, we subtract minus 3 from the denominator. We get 5. 5 is the remainder. Alright, now let's take another example, some different type of problem here, 4 factorial by 8. Now for those people who do not know what a factorial is, I will tell you in very short right now here. Factorial means the continued product of natural numbers. Like for example, n factorial means continued product from 1 to till n numbers. For example, if you are given 7 factorial, then now this is from 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5 multiplied by 6 multiplied by 7. Now let me tell you just clear that this is not the complete theory about factorials and everything. We have to learn all the principle of counting and everything else. We'll go about that in different details, but for now onwards you should know that 4 factorial means 4 into 3 into 2 into 1. That is more than sufficient for this lecture. You don't have to. Alright. Now in this example, what we are going to learn is, as we know that we are asked what remainder we will get when we divide 4 factorial by 8. As you can see, when we multiply 4 by 2, in this example, as you see that when we multiply 4 by 2, what do we get? We get 8. Now 8 gets cancelled with another 8. Hence, the factor of the denominator is present in the numerator itself. Let me clarify this thing to you for more clearly. We are dividing the above expression by 8. So we are supposed to divide it by 8, but as we can see, when we multiply 4 by 2, we get 8 itself. Hence this means the factor is present in the numerator itself. Therefore the remainder will be 0 directly, because it is completely divisible. When remainder is 0, what we say is that the number is completely divisible. Then the next example, as you can see, 5 factorial by 7, there is actually no trick that you can use here. 5 multiplied by 4 multiplied by 3 multiplied by 2, and the remainder is, we cannot apply anything, because even if we try making the trick here, because it will give us plus 5 plus 4 plus 3 only, and the result will be the same. So what do is we multiply the numbers actually, that is 5 into 4 is 20, 23 is a 60, 62 is a 120. So we actually divide the number 120 by 7 and check what the remainder will be. So I guess the remainder will be 1, because 119 is divisible by 7, if I am not wrong. Okay, let's moving on to our next example. The number is 3 factorial upon 10, as you can see. Now the 3 factorial upon 10 represents, what is 3 factorial? 3 factorial is 3 into 2 into 1, which is 6. Now in this case the question will never come like this 3 factorial upon 10. The question is what will be the remainder, what will be the units place of 3 factorial, units place, what will be the remainder at the units place. The question will never be like this. They will ask what will come at the units place of 3 factorial. Now you have to understand that when we are asked about the units place, we have to divide the number by 10. They will ask about the units place. In the following example, they will ask about the last 2 digits of the number. So as you can see, to find the units place, we divide the number by 10, and in this example you can do 2 things. Either you can write directly the remainder is 6, but if the expression is complicated, then you will use the previous trick, that is the number will be minus 4. The minus 4 cannot be example. So what do? Is we subtract this minus 4 from the denominator, and the result is 6. Now in the next example, as we see is the result is 4 factorial by 10. In the same example, we will be asked the units place. What do? Is that the number is plus 4. The number that we can write is plus 4. Now the remainder is exactly plus 4. All right. That's it for these questions. Can be asked from the factorial series. They are not really difficult if you keep certain tricks in your mind.